Okay, so I'll just kind of review the whole RoboSumo circuit, like a basic version of a RoboSumo circuit. There's going to be a number of components here that we're going to rely on. So I suppose the first and most important one is the Arduino. So I'm just going to draw it in here as a kind of a rectangular block. And I'm not going to show all of the inputs and outputs. It's got a lot of pins. I think it might be 28 pins maybe altogether. But I'm just going to write in Arduino Nano. And in order to run the Arduino, the first thing we're going to need to do is to connect some power. Now, nominally, I think you can either connect a voltage source to the voltage, I'm trying to think, to the unregulated voltage input. So typically people will connect like a 9-volt battery. I think 7 volts might be the minimum there, or something like that. But what we're going to do is we're going to connect in, we're going to skip the voltage regulator, and we're just going to connect in our 6-volt battery pack. Now, strictly speaking, that's probably not as specified by the Arduino spec, but you know, we're just going to do that anyway. It seems to work okay. So here's my 6-volt battery pack. That's the this 4AA battery pack here, so it's going to have 4 AA batteries in series. And I'm just going to draw some nice long bars at the top and bottom. These are what we call the rails in the circuit. So up here we've got a 6-volt rail, and down here we've got a 0-volt rail. So the reference voltage in some ways is arbitrary, but whatever the voltage is at the negative terminal of the battery, we're going to call that 0. And voltages everywhere else in the circuit will be relative to that reference voltage there. So I'm going to connect into the ground pin. Now there's actually a couple of different ground pins on the Nano, so it shouldn't really matter which one you connect to for this circuit. And this is going to go into V in. So the pins on the Arduino Nano are labeled. So you should find these labels on the pins. So once your Nano is in the breadboard, you can just connect wires into the rows where these pins are. Okay, I'm going to imagine that I'm going to control 2 motors. So let's picture a robot here which has got 2 wheels, some kind of a chassis. So here's the 2 wheels, and we'll imagine that there's a motor driving each of the wheels. So a motor in there somewhere, right? It's got 1 wheel on the left, 1 wheel on the right. And the way that the robot is going to maneuver is if it drives the 2 wheels forwards. Both wheels drive in a forwards direction, the robot will drive forwards. If you reverse both motors, it will drive backwards. And if you drive them in opposite directions, you can either rotate the robot clockwise or anti-clockwise. So our Arduino needs to be able to control the direction either forwards or backwards of 2 motors here. Now you can't connect the motors directly to the Arduino, and the reason is that the motors require too much current to get them turning. It would exceed the allowed current for each of the Arduino pins, and you would either just not see the motor turn at all, or potentially you could damage the pins on the Arduino or blow the entire Arduino. So what we're going to do is we're going to use what we call a driver chip. The specific one that we're going to use is called SN754410NE. So not a very catchy name, but this is a very, very useful chip. It's a 16-pin device, and it has effectively got 4 channels in it. I'm going to draw them in like this. This is kind of illustrative rather than literal, but it's like you've got 4 inputs, each of which controls 1 output. So 4 inputs, 4 outputs. These are binary channels, so you basically send in a signal into each of these inputs, which is either high or low, and you get a signal out each of the outputs, which is either high or low. But the difference is that the current that comes out is much bigger potentially than the current which goes in. So we can use these outputs here to drive high current loads like motors, for example. So I'm going to connect up 1 motor here. So I'm connecting this motor, let's call this the left motor of the robot, so that'll be the one on the left wheel here. And I'm going to connect my other motor to the other two outputs. And we now have got a sort of a controllable motor block. We can put in small current logic signals into these 4 inputs, and we'll be able to control the direction of both of these motors, either forwards, reverse, or stop for both motors. That's the right motor here. So I'm going to connect 4 outputs, digital outputs from the Arduino into here. So the software that we write and that we run on the Arduino is going to switch the voltage high and low on these 4 outputs. I'm just going to pick random outputs here, let's say D3, D4, D5 and D6. So I'm not picking them for any specific reason, I've just randomly selected 4 digital output pins on the Arduino, and it'll be very straightforward for us to encode set the voltage high or low there. So what we're going to see coming out here will be, I'm going to call it 6 volts, it could be 5 or 6 volts, but let's say the output here will be either 6 or 0 volts, depending whether we set it high or low. Same thing here, 6 or 0, 6 or 0, 6 or 0. And we're going to see the same voltages coming out here, basically, except that the current, as I say, will potentially be much larger than the current flowing in these wires here. Now, of course, we can't have lots of power coming out of this chip here unless that power is coming from somewhere. The amount of power transferred from the Arduino to here is quite small, right? Very small, in fact. So the power that's delivered to the motors has to come from somewhere. So our driver chip here needs to be connected to the battery supply via the rails, the 0 volt rail and the 6 volt rail. In fact, there's 4 ground pins. So I'm just going to show them all connected here. So there's 4 ground pins, and in fact there's 2 power inputs that need to be connected. So I won't put in the pin numbers here, but these are the pins which need to be connected. So altogether we're going to have a total of 14 pins on this 16-pin chip connected. There are 2 additional pins which are enable pins, and we're not going to use those.